Welcome to the Deep Dive Learner. So when you picture the absolute worst case scenario, like the end of the world as we know it, there is a very specific movie reel that plays in all of our heads,
Right.
right?
The classic Hollywood apocalypse.
Exactly. We expect a blinding flash of light and then that iconic, terrifying mushroom cloud rolling over a city skyline and, maybe some toxic glowing snow drifting down over a barren wasteland.
Yeah, and in that cinematic version, the blast radius is, well, it's everything. I mean, if you aren't vaporized in the initial fireball, your entire focus just narrows down to finding a basement and hiding from the radiation.
Right.
It really frames survival as this very immediate, highly localized challenge.
It's treated as binary. You're either in the fireball or you're out. But we have a massive stack of sources here today.
We really do.
Yeah, we've got detailed breakdowns of global survival strategies, climate models, agricultural data, and government bunker systems. And looking through it all, it completely dismantles that pop culture image.
It really does. It flips it on its head.
Yeah, so our mission today is to completely rewrite your understanding of what surviving a global conflict actually looks like. Because looking through this research, the bomb itself, well, it isn't the real threat.
No, the initial detonations are really just the opening act. The actual civilization-ending threat is entirely logistical.
It's logistical.
Yeah, it's a crisis of agriculture, supply chains, and basically what happens to a highly interconnected planet when the sun disappears.
I want to jump straight into the mechanics of that because the numbers in this 2022 Rutgers University study, the one led by Lily Shia and Alan Robach, they are just staggering.
They're terrifying, honestly.
Yeah. So they ran the models on an all-out U.S.-Russia exchange, and obviously the immediate casualties from the blasts are horrific. But the mechanism that kills the vast majority of humanity is something else entirely.
Right, because the models take the destruction a step further. They look at the aftermath of the fires.
The firestorms.
Exactly. When you have thousands of warheads hitting military targets, industrial centers, major cities, those explosions ignite massive continent-spanning firestorms. Wow. And those firestorms become so intense they actually create their own weather systems. They're called pyrocumulonimbus clouds.
That sounds like a mouthful, but basically they act like massive chimneys, right?
Yeah, exactly like chimneys. They pump roughly 150 teragrams of black carbon soot directly into the upper atmosphere.
Wait, 150 teragrams of soot? We are talking about mountains of pure black carbon floating above us.
Oh, absolutely. And the altitude is the crucial detail here.
How so?
Well, because of the intense heat driving those chimneys, this black carbon is pushed into the stratosphere, so it's well above the troposphere, which is where our everyday weather and rain clouds live.
Oh, so because it's above the rain, it doesn't wash out.
Exactly. It doesn't wash out. It just sits up there, enveloping the northern hemisphere, and it acts as a permanent global sunshade.
So the lights literally go out.
Yeah, sunlight is physically blocked from reaching the surface. The models show global temperatures dropping by 10 or more degrees Celsius for years.
10 degrees.
Yeah. And to put that in perspective, a 1-degree drop in global temperature is enough to heavily damage Canada's entire wheat crop.
Wow.
So a 10-degree drop means rainfall over the world's major breadbaskets just completely plummets. The growing seasons simply vanish.
We need to just sit with the statistics from this Rutgers study for a second because they are chilling. Within 3 to 4 years of an exchange like that, global caloric production falls by 90%.
90% is almost total collapse.
Yeah, and the estimated death toll is 5 billion people. But, the detail that really stopped me in my tracks was the geography of those casualties.
Oh, the location.
Yeah, most of those 5 billion people die from starvation, and the vast majority of them live in countries that were never targeted by a single warhead.
It fundamentally redefines the whole concept of a target zone. I mean, the blast might kill a few 100 million people, but the resulting global famine kills 5 billion.
Right. And the study didn't just look at the worst-case scenario either. They also modeled a localized regional conflict, like, say, an exchange between India and Pakistan, using only a tiny fraction of the global nuclear arsenal.
Yeah, and even that localized scenario drops global crop production by 7%.
7% doesn't sound like a lot at first, but in agricultural terms, that's huge.
It's massive. That would trigger the single worst agricultural drop since reliable records began in 1961.
Wow.
It would eclipse any drought, volcanic eruption, or climate event in modern history. The interconnected nature of our food supply means a regional war stars people on the completely opposite side of the planet.
My initial instinct, and I think the pop culture instinct for most of us, is to just hide it out. Like, you hear the sirens, you go underground, you lock the door.
Sure, that's the natural reaction.
But looking at the timeline of this soot, hiding in a bunker is like locking yourself in a bank vault to survive a hurricane, but forgetting you need to eat for the next 3 years. Like, the vault protects you from the wind, but it doesn't generate calories.
That's a perfect analogy. For decades, our entire global defensive posture was based almost exclusively on just pouring concrete.
Right, just building thicker walls.
Exactly. But when you look at the real-world applications of those bunker programs, you see how quickly the logic falls apart without a broader logistical system. We can actually compare two radically different approaches to this, starting with Switzerland.
Okay, yeah. Switzerland has always been viewed as like the ultimate safe haven, right? Neutral since World War II, surrounded by the Alps, but they went incredibly hard on the concrete.
Oh, very hard.
Since 1963, they've mandated that every new building include a shelter. Or if they don't, the builder pays a fee into a communal fund so the government builds one. They currently have 370,000 bunkers.
Which is staggering.
It is. That's enough space for all 9 million residents, plus a significant buffer.
But, what sets the Swiss model apart isn't the volume of the concrete. It's the fact that it's a meticulously maintained, system-based readiness program.
Right. It's not just a hole in the ground.
Exactly. For roughly 1,400 Swiss francs a spot, the engineering includes heavy blast doors and sophisticated NBC filtration networks. That's nuclear, biological, chemical. But more importantly, the government treats it as active infrastructure.
Yeah, they have strict 5-day readiness protocols. They actively run inspections to ensure the air filters still work. I mean, people might use them as wine cellars or music rehearsal spaces during peacetime, but the operational capacity is heavily regulated.
Yeah, it's all ready to go.
They even built the Sonnenberg Tunnel in Lucerne, which was originally designed to hold 20,000 people. It had command posts, showers, operating theaters. It was basically a functional subterranean city.
It's incredibly impressive. Now, look at the complete opposite of that system's thinking.
Yeah.
Look at Albania under Enver Hoxha's regime. This was from 1944 to 1985.
Oh, right. Hoxha.
Yeah, Hoxha was intensely paranoid, and he completely isolated his country. His administration's response to the threat of conflict was to just build over 173,000 concrete domes across the landscape.
That's roughly one bunker for every 16 citizens. I read that if you drive through the Albanian countryside today, you just see endless fields of these concrete mounds.
Yeah, they're everywhere. But the fatal flaw in Hoxha's plan was a complete misunderstanding of the threat.
How so?
Well, those mounds were built for 1940s conventional infantry warfare. They were basically designed as pillboxes for soldiers with rifles.
Oh, wow.
Building them severely drained the nation's GDP. That was capital that could have modernized their agriculture or power grids.
Yeah.
And they lack every essential survival mechanism.
So no air filtration.
None. No municipal water tie-ins.
Yeah.
No long-term food storage.
So Albania built 170,000 concrete umbrellas for a flood.
That's exactly what they did.
But, looking at the Swiss system, even with the best filtration and the most rigorous inspections, eventually the canned food in those Lucerne tunnels runs out.
Oh, absolutely.
If the meticulous Swiss system only buys you a few weeks or months underground before you're forced to emerge into a freezing, sunless world where no crops can grow, the bunker just feels like a very expensive delay of the inevitable.
Yeah, emerging from that bunker means stepping into a world with no global trade, fractured supply chains, and a collapsing biosphere. The survival paradigm has to shift away from hiding and move toward complete, isolated self-sufficiency.
Okay.
You really need a geographic location that can operate entirely independently of the rest of the planet.
Well, if we're looking for an isolated, self-sufficient geography, my mind immediately goes to the ultimate internet survivalist fantasy, which is Iceland.
Ah, yes. Iceland.
It's incredibly remote. It has a tiny population, around 380,000. It seems like the geopolitical equivalent of hiding in a room nobody remembers exists.
The appeal is obvious, for sure, especially when you factor in their infrastructure. Iceland pulls nearly 100% of its electricity from geothermal and hydroelectric sources.
Right, they're just actively tapping into the heat of the earth and the flow of their rivers.
Exactly. So if the global supply of coal, oil, and natural gas vanishes overnight, Iceland's power grid doesn't even notice. Their lights stay on, their homes stay heated.
It looks like an absolute cheat code for the apocalypse. You have endless clean energy and hot water while the rest of the world goes dark.
It creates a very compelling illusion of safety. But the research highlights two fatal flaws with Iceland.
Okay, what's the first one?
First is the strategic reality. Iceland is a NATO member. During the Cold War, the Keflavik Air Base was a critical installation for monitoring submarine traffic.
Right.
It sits right in the GIUK gap, which is
Mhm.
the naval choke point between Greenland, Iceland, and the UK. So in a major conflict, that geography makes it a prime strategic asset. It is very much on the radar.
So geography pulls you into the conflict whether you want to be neutral or not.
Exactly.
But even if we pretend the military aspect doesn't exist, the agricultural data points to a much bigger problem. The soil in Iceland is mostly thin volcanic rock, and the growing season is already incredibly short.
Yeah, they just don't have the farmland. Iceland imports the vast majority of its food. They rely heavily on massive container ships arriving from Europe and North America just to keep the population fed.
And under the Rutgers nuclear winter model, those ships stop sailing entirely.
They do.
I was reading through the marine models, actually, trying to find a loophole for them, because they are an island surrounded by highly productive fishing waters. If the container ships stop, couldn't a population of 380,000 just pivot entirely to an ocean-based diet, just eat fish?
You'd think so, but no. The physics of the soot cloud shut that down entirely.
Right?
That same 150 teragrams of black carbon that blocks the sun over the wheat fields of Canada, it also blocks the sunlight from penetrating the surface of the North Atlantic.
Oh, wow. I didn't even think of that.
Yeah, marine ecosystems rely entirely on phytoplankton, which need sunlight for photosynthesis. When the sun disappears, the phytoplankton die off in massive numbers. And because they are the foundational base of the entire oceanic food web, marine productivity crashes. The fish simply won't be there.
That paints a deeply haunting picture. You're sitting in a perfectly heated, fully illuminated house in Reykjavik, taking a hot shower, and you are slowly starving to death as the supermarket shelves empty and the oceans go barren.
It's a grim reality check.
Yeah. So if endless clean energy can't save you without a localized food supply, we have to look for the places that actually have the agricultural buffer to weather a 90% global drop in calories.
Right, and for that, we have to look toward the southern hemisphere. In 2022, researcher Matt Boyd and his colleagues published a really fascinating study. They evaluated 38 island nations on their ability to survive a sudden, catastrophic collapse of international trade.
Okay.
They analyzed energy independence and manufacturing, but the heavy weighting went to localized food production.
And Australia took the #1 spot on that list.
They did. Australia dominates that ranking almost entirely due to its massive structural wheat buffer.
A wheat buffer.
Yeah. Even if you completely sever every trade route, cut off all fuel imports, and totally isolate the continent, Australia produces enough excess grain to cover roughly 50% of its population's caloric needs almost indefinitely.
Wow. And New Zealand came in second in that same Boyd study. They have abundant fresh water, incredibly diverse agriculture, and a population of only about 5 million.
Right. They have a lot working in their favor.
The sheer math of food distribution actually works out for them. It's no secret that tech billionaires have been quietly buying up vast agricultural estates in the New Zealand countryside for the last decade. They are reading this exact same data.
Oh, absolutely they are. It's the agricultural capacity combined with a massive geographic shield.
A geographic shield? What do you mean?
Well, the northern and southern hemispheres don't share air circulation as freely as we might assume. There's a meteorological phenomenon near the equator called the Intertropical Convergence Zone, or the ITCZ.
Oh, yeah, I looked into the mechanics of the ITCZ because calling it a wall sounded like magic. It's essentially where the trade winds from the northern and southern hemispheres collide.
Exactly.
And that collision forces the air upward, creating a permanent band of intense low pressure and massive thunderstorms.
Yeah, and that constant upward momentum acts as a heavy atmospheric barrier. It's not an impenetrable seal, but it dramatically slows the transfer of particulates between the hemispheres.
Okay.
So the vast majority of the black carbon soot and the radioactive fallout from a northern conflict gets caught in those global wind patterns and remains trapped in the north.
Wait, really? So the South just avoids it?
Well, the southern hemisphere would still experience significant climate cooling and disruption, for sure, but they would avoid the deep freeze that completely halts photosynthesis.
Okay, but the Boyd study introduces a really grim variable to this lifeboat theory, though. The agricultural math in Australia works perfectly for 27 million Australians, and the buffer in New Zealand works for 5 million New Zealanders.
Right. The carrying capacity is strictly defined by those numbers.
So if the northern hemisphere goes dark and crop production drops by 90%, we always assume distance protected us from the blast. But distance is just a buffer that buys time before the rest of the starving world gets on boats.
Yeah.
If Australia suddenly has 60 million desperate refugees arriving on its shores, their self-sufficiency math just shatters.
It does. A sudden massive influx of population collapses the exact agricultural and logistical systems that made the location a lifeboat in the first place.
Okay, well, most of us listening to this don't live in New Zealand, and we certainly don't have the capital to buy a self-sustaining underground compound there. So if we step away from the geopolitical lifeboats for a second, I was looking through the declassified government manuals you brought in just to see what ground-level survival actually looks like for the rest of us.
Yeah, those manuals are eye-opening.
They really are. The thing that blew my mind wasn't some billion-dollar sci-fi technology. It was dirt.
Yeah. Ordinary dirt. Because the actual physics of a nuclear event are far more forgiving than the pop culture narrative suggests.
Really?
Yeah. Take the blast wave itself. If a 1 megaton warhead detonates, that initial shock wave expands at roughly 2,000 miles per hour. But the energy dissipates exponentially as it travels.
Okay.
Within just a few seconds, it drops down to the speed of sound. If you're even a few miles outside the immediate destruction zone and you have, say, 10 seconds of warning, simply taking hard cover dramatically increases your odds of surviving the pressure wave.
The radiation shielding math is even more surprising to me. We've been conditioned to think we need lead-lined walls and submarine-style airlocks. But the manuals state that 36 inches of packed, ordinary backyard dirt blocks fallout radiation just as effectively as 4 inches of solid lead. 3 feet of dirt.
Yeah, it basically comes down to basic density. Mass is mass when you're trying to block ionizing radiation.
Yeah.
Furthermore, radiation from fallout relies heavily on line of sight.
What does that mean for a shelter?
Well, the particles and energetic photons travel in straight lines. They do not turn corners well without striking something, scattering and losing their lethal energy. So if you dig a trench and build a shelter with a right-angle zigzag entryway, you immediately drop your interior radiation exposure by 95%, without needing a single mechanical seal.
That's wild. And the ingenuity in these manuals extends to the equipment, too. I really want to talk about the KFM, the Kearney Fallout Meter. This was developed at Oak Ridge National Laboratory.
The KFM is brilliant.
Right. Pop culture says we need digital Geiger counters, but the KFM is built out of household trash. It's literally a tin can, some aluminum foil, a piece of thread, and some drywall gypsum.
It is a masterclass in practical physics. The KFM operates on the principle of static electricity. You build the meter and charge the two small leaves of aluminum foil so they naturally repel each other, standing apart.
Like rubbing a balloon on your hair.
Precisely the same concept. When ionizing radiation enters the tin can, it literally knocks electrons off the air molecules inside, making the air slightly conductive.
Okay.
That conductivity allows your static charge to slowly leak away. As the charge drops, the aluminum leaves fall closer together.
That is so simple but so effective.
It is. You measure the radiation levels in your shelter simply by timing how fast the foil leaves move. And when government agencies tested it, this tin can device actually proved more reliable and accurate under field conditions than many of the factory-produced dosimeters sitting in official stockpiles.
A family with a shovel, some backyard dirt, and a couple of soup cans can effectively build a mathematically sound survival setup in about 36 hours.
Yeah, it's totally achievable.
The blast and the immediate fallout aren't insurmountable sci-fi obstacles. But looking at the broader picture, humanity's actual sci-fi backup plan isn't a bunker for people at all. It's a bunker for plants.
The Svalbard Global Seed Vault.
Yes, deep inside a sandstone mountain on the island of Spitsbergen in Norway, about 800 miles from the North Pole. The Norwegian government spent roughly $8.8 million to carve this facility 120 meters deep into the rock.
It's an incredible facility. It's the ultimate expression of system-based logistics applied to the biological legacy of the entire planet.
Right.
If a nuclear winter destroys global agriculture, thousands of years of human botanical engineering just vanish it. Svalbard holds roughly 1.3 million individual seed samples. And the genius of the engineering is the location itself.
Because of the cold.
Exactly. The ambient permafrost naturally keeps the vault at a constant negative 18 degrees Celsius. Even if the facility loses mechanical power, the mountain acts as a permanent natural freezer.
And looking at the manifest of what they store there, they aren't just hoarding the high-yield, perfectly optimized modern wheat we use today. They actually prioritize the wild crop relatives. You know, the gnarly, unrefined ancestors of our food.
And that is a critical distinction. Modern crops are heavily optimized for our current highly stable climate.
Right, they're a bit delicate.
Very delicate. If humanity emerges into a post-nuclear winter, where the growing seasons are drastically shorter, ambient temperatures are heavily reduced, and sunlight is weak, our modern crops will completely fail.
So we'd need the older ones.
Exactly. We would need the rugged, unrefined genetic diversity locked in those wild strains to rapidly breed entirely new varieties of crops capable of growing in a hostile biosphere.
It's basically an active insurance policy, and we've actually had to make a withdrawal. Back in 2015, the International Seed Bank in Aleppo, Syria, was severely damaged during their civil war.
I remember that.
Yeah, researchers literally went to Svalbard, retrieved backup seeds from the permafrost, and shipped them to Morocco and Lebanon to successfully rebuild the collection. It works.
It does.
Though, the mountain isn't invincible. In 2016, unusually warm global temperatures caused the permafrost to melt slightly, flooding the entrance tunnel of the vault.
Oh, right.
The seeds remain safe, but it's a stark reminder that even our ultimate backup plans are vulnerable to the climate.
It really is. And it proves that the true long game of human survival isn't about hoarding bottled water in a basement. It's about preserving our foundational capacity to rebuild the complex agricultural systems that allow civilization to exist at all.
So what does this massive stack of sources actually mean for you? Let's bring all this data together. The pop culture image of surviving a nuclear conflict, hiding from a fireball in a concrete box, is a distraction.
A huge distraction.
Surviving the blast wave and the immediate radiation is a matter of basic physics, dirt, and simply being out of the immediate target zone. The true apocalyptic threat isn't the flash. It's the 150 teragrams of black carbon soot. It's the 10-degree drop in global temperatures. It's the 90% collapse in the global food supply.
True. Long-term survival is dictated by geography, by massive agricultural buffers, and by meticulous logistics.
Right.
Whether we are analyzing Switzerland's maintained filtration networks, the permafrost cooling of Svalbard, or Australia's structural wheat reserves, the conclusion is exactly the same. You must be positioned in a system where the sun still shines enough and the crops still yield enough calories to feed the people standing there.
But I want to leave you with a thought that really lingers from the Matt Boyd study. It points directly to a moral dilemma that physics and agriculture simply cannot answer. It's a tough one.
We establish that Australia and New Zealand represent the ultimate lifeboats. They have the caloric buffers, they have the water, and they are shielded by the atmospheric wall of the ITCZ.
Right, but their survival relies on a delicate, mathematically rigid carrying capacity.
Exactly. If the Northern Hemisphere goes completely dark and hundreds of millions of starving, desperate people board ships and head south toward the only places left on Earth capable of growing food, what happens?
The models explicitly state those island nations only survive if they maintain their logistical balance.
Right. So what moral compromises will those safe nations be forced to make to ensure their own survival? Do they militarize their borders against starving refugees? Do they sink the boats? You might survive the nuclear winter by being lucky enough to live in the southern hemisphere, but what kind of society emerges when the fundamental cost of your survival is turning your back on the rest of humanity? It forces us to ask if surviving the apocalypse simply means losing your humanity in the process. Thanks for taking this deep dive with us. Catch you next time.